Hello, I'm Patrick Brown, and I was part of the website development section of our project.
I'm Nicholas. I work on the application and database management as well as like the backend script building for our sports and website application. So this is our project overview. So we want to design a website and application that uses Google generative AI to summarize articles. But mostly, we don't want to just summarize the article, we want to just give enough information where you can kind of decide whether you want to read the article on your own, because we don't want to give all the information in our summaries, because we want to be able to send you to the actual article so you can read the full information. The information is collected through P.2 library as well as the News API. The website and application covers the MLB, NBA, and NFL. We use Google's Firebase platform to host the website as well as the database for all of the data that we collect throughout the project.
And so when we initially started our project, we didn't have much of a background in website development or working with any application or any AI in general. So we were recommended to go to Dr. Afshar, who had a background in these materials, to learn from him. And we met with him to discuss how to proceed with our project. And so we were given details on how to use specific APIs and what tools that we should use during development, as well as other useful information such as how to prompt AI and an API in certain parts to use to grab relevant information. And so he was really good in providing that information. And he also recommended resources such as YouTube and GitHub to post our website development progress as we just coming up. And so for the initial website development of the project, we chose to use VS Code to write all of our code because it's a really robust development platform that we can use for a variety of different languages, and also it provided useful tools such as autofill and code correction. And so the website was coded in completely raw HTML, CSS, and JavaScript. We wanted to create the website specifically from scratch without using any separate hosting solutions that would create the website for us. We wanted to really show off what we had learned, and so we wanted to code this from scratch. And we also used the live server plugin that was being used to be able to see real-time changes while we worked with our code. So for example, if I was coding a web page, I could see in real time what changes were actively being made to the website as I was making changes. And so along with choosing that platform, we also use resources such as a YouTube channel called Broco. And this channel provides a vast amount of resources for any specific coding languages, and offers free tutorials and practices on how to learn certain languages. And so I used the Broco HTML and CSS video to teach myself HTML and CSS coding concepts and functions. And the other video covered concepts that I developed throughout the project included working with websites in HTML and CSS to embed YouTube videos, embed audio files into websites, and be able to create different layouts with CSS, and also create other elements with CSS and HTML combined, such as scroll wheels, scroll boxes, creating icons, and adding animations to the website to make it more robust. And so during development, the first thing I wanted to do was create a navigation panel for the website to be able to navigate between different sections depending on what category users select. And so right here is a basic navigation bar that I created using HTML list references to be able to reference specific web pages in the files, and I use CSS to style the background. The next thing that I created after I created the navigation bar was I wanted to create a form code page to be able to have users put information back into us if they wanted to submit specific information, like if they wanted to use our details or request a change. And so we created a specific, just simple form just to be able to practice the concept using the form functions to be able to add labels and inputs for each types and be able to store those within variables. And so the next thing that I created after that during practice was I wanted to be able to have users be able to see the entirety of a summary without having to go to the next page, for example, because depending on what article we summarize, there could be more information, there could be less information. And so we wanted to make sure that all information provided from an article could be viewed at once at the same time on the same page. And so with that, we created an overflow page right here with the scroll wheel so that no matter what article a user was reading, they could read the entire frame on the same website. And along with that, I was able to create icons using references to specific images, to be able to create icons for the website, to be able to add different elements and decorations. And before deciding on using a navigation bar, I also worked with pagination to be able to go sit through different pages. This early on in development, we weren't sure how many articles we wanted to have per page, per category. And so this was created to be able to hold, per se, like, if I wanted a second page of specific MLB articles, that was created there to hold those different articles, but we eventually chose just to have just 20 articles per page, not to overwhelm users, and to keep it more concise on what we reported. And also during development, I worked with making animations on different elements on the websites. And so I used the keyframes CSS function to be able to create specific animations for example, like our title or anything else we wanted to add to the website to be able to create dynamic animations to make the website more stylish. And so, for example, this keyframe slide left function and variable that was used to be able to like say, oh, I want this element to translate on the x-axis this amount of time to be able to choose where I wanted animations to start and stop. And so once we went through that initial development, the initial website structure was created. And so here's just a basic early prototype of the structure we created. We wanted to have our title here, we wanted to have a little subtitle here, we wanted to make sure the navigation bar was at the top and formatted to the left, and so that element ended up being in our final design. And when deciding on how to structure the articles on the page, I decided to create them in a categorized format with having the title of whatever category would be, whether it be the main feed where it has a mix of all articles or just MLB, just NBA. And so the structure of the website was chosen there to be able to hold them in their own container. Each article was held in their own container so that it would be divided up for users to be able to pinpoint which articles they may want to read, and also just keep it condensed to where there isn't just an overflow of articles on one page to be able to keep them categorized and together. And so once I created the initial structure, the hosting solution was then needed to be found to be able to actually host the website and have it up on the internet. And so we chose to use Google Firebase, which offers website hosting that can be linked to, for example, a project file. And so with our different elements of our website was created using Google Firebase. And so we were able to host the website in those same project files to be able to connect each of the elements together. And so our database was being hosted by Firebase Firestore, and so we were able to connect the website and our database together really easily because of hosting them in the same project. And I was able to create the hosting solution for the website by following specific Firebase documentation on how to actually upload the website to Firebase. And that was just a simple process of following specific commands in the Windows command line and deploying the website from there. And whenever any changes happen to the website, just going back to that same directory within the Windows command line to upload the website if any changes were made. And so when connecting the database, we originally had planned to use PHP, which would to connect the database to the website, but we switched to using Firebase functions and import functions due to Firebase being our hosting solution. That way it was a much easier process to be able to host the website having instead of having like a separate outside source to host the website. And so Nicholas assisted with this part due to having experience writing code in JavaScript. And so he was able to connect the website and the database together using JavaScript code. And the database was connected to the code using specific import functions provided by Firebase documentation. And so in the upcoming code that comes up, the doc collection variable that we used was used to store the results of whatever query we wanted to create, such as I want this amount of articles based on this category of sport at the earliest timestamp, and specifically a certain amount of words, even if we wanted. And so we were able to store the query from what we were able to store the query inside the stock collection variables and order them by specific limitations that we wanted. And the snapshot variable was use with the get function to be able to collect the query and store those results into an array. And then after that, we were able to parse the array with the display articles function to then push the results of the query onto the website using different HTML elements and CSS ID tags. And so, for example, up here is where we use Firebase documentation to collect certain functions that we would need during the initial writing of the JavaScript. And so, for example, we have the collection function, the query function, the order by function, the limit, and the get docs function, which was used to be able to pull from the database, query it, order it, limit it, and get the doc from the database. And so from there, we were able to pull our queries, put them inside a function and our function articles, and then we were able to display them using HTML elements with CSS ID tags. And so this is what the website ended up looking like in another earlier version with the database connected to the website, being able to have the article title and image, what the author was, and then the summary underneath. And then so for the final website design, we chose to go with a black background with gray accents for the article to make the articles easier to read depending on the background. And we also chose a column design for the articles to keep them condensed and make it easy to view, for example, on a phone screen if for some reason a user didn't want to use the application equivalent of the website, to be able to keep that with parity with the application so they look pretty much exactly the same. We chose an Arial font with white text to make it easier to read, and the final website can be viewed at this URL along with the files that were created during development to be able to review our code development. And so here is a video of the final version of the website where it has our article name, our images, our reference, and the specific summary. And if users decide, ooh, I really like that article, this sounds interesting to me, they can go and read that article on the official site where it was referenced and be able to do that. And on our navigation bar, they're able to query just specifically, oh, I only want MLB, I only want NFL, I only want these specific sports, and then if they're interested in these articles, they can reach those main articles, and it just really gives an accessible way for people to find the information that they're interested in quickly without having to read an entire article and then oh, I didn't like that, I wasted my time.
Okay, this is what I worked on. I worked on the backend script in the database. So it's all written in Python. It automates fetching articles from the news API, and that's sent and parsed through the Python script. And then that is also sent through the AI afterwards, after it has gotten the data from the news API as well as web scraping. It puts it into the AI. And then it's uploaded to the Firebase Firestore, and then it is able to be pulled from the website in the mobile app. It just runs standalone on my computer. I have it set up so it can start at in the morning, whenever at 7 a.m. But I don't have it enabled right now because I just don't want it to waste resources that it doesn't have to. So this is how the data is stored. It holds an author, 3 bullet points, a category, an image URL. So there's an image on the article. It pulls the source, the timestamp, the title, and the URL. The timestamp so we can actually order by descending time whenever we want to show it on the web page. So for services and libraries, we use News API Client. It's an unofficial library, but the News API supports it and recommends it to use. We use .env. It loads the API keys so we don't have them in plain text, so I can post this on GitHub without getting charged $1 million. We got Firebase admin, allows us to communicate with the Firestore database, and then, well, you have to use this key to actually write to the database. You can read from the database without any key, but writing you need the key, so we use this as well. Google Gen AI, we use that to use the generate content function, and it allows us to prompt it to give us results. As well, we use Beautiful Soup 4. It's a web scraping library. It allows us to pull the content of the article. So for pulling news articles, we use the News API client library to receive a basic set of articles. And so we pull 80 articles at the moment. We used to have to pull less, but we have a higher rate at this point. So we try to get NBA, MLB, or NFL in the title. We use these specific domains that I've chosen as decent sports sites. Choose English, you sort it by relevancy. We had to add a gambling filter because if you notice back here, so this is like half the articles that get posted for sports. It's just play $5, get 75 in free bets. So we kind of just want to avoid having to even see that. So for that, we added essentially a gambling filter. We have block title keywords such as like bonus or odds or bet. Things you just don't want to end up seeing because it's just an advertisement that has no information about sports you care about. So web scraping with PS4. So it's a web scraping library for Python, searches the HTML page. We use it to pull all the paragraph tags as well as image tags, so we can try to find the image URL as well as all the paragraph information on the page so we can send it to the AI. We cap this at about 5,000 characters because we have rates on the AI that we can only use a certain amount of tokens per minute, so we have to limit this. It respects robots.txt, but I've also manually checked, and they allow user agents to look at different articles. For user agents, most of them don't allow you to look at box scores or stat pages, but for most article pages, you're good. As well, we also don't pull very many times from each source either. ESPN and a few others also include sitemap, which would allow us to directly essentially go around using News API, and we could just look for articles directly from ESPN specifically, or whatever other page has a sitemap. For bullet point generation, this is how we get essentially the AI summary. This is the prompt. It takes the bullet instruction, and then the title, and then the content that we pull from the content comes from the web scraping, so it returns a variable with 5,000 characters of text and a string, and then sends it through the content with the bullet instruction and the title. So we ask it to generate 3 bullet points that encompass the main important points of the article. There should be about 1 sentence each and to be preceded by a dash character. We choose a dash character because we want to know where each bullet point should start and begin. If we were to ask the AI 3 times in a row for 3 bullet points, the way we are using it is not conversational, so it won't remember that we already asked it before, so it'll just give us whatever it decides is important for that point. So you could get 3 of the exact same point, essentially. So for rate limiting, we learned a lot about rate limiting throughout the project. So we use the free version of Google Gemini AI. So that essentially allows us to use a lot of Gemma, which is a lightweight model, but we can't really use a Flash or a Pro model because you can only do about 20 requests per day, and that is really limiting. So, but on the other hand, the Gemma models, they allow you to use up to 14,000 requests per day, which is a really big difference. We chose to do the free subscription, but it was also ranked really highly back in December and January as one of the best AIs on the market. I don't believe it is as of now. Very low rates on the higher quality models, like I was saying, 20 per day. We're using Gemma 27 billion parameter model with 14.4K requests per day. This is obviously way more than we need, but there is no middle ground on this at all. So we want to use Gemini 2.5 Flash, but it only has the 20. But it'd be probably a lot better quality of answers. Gemini models are just slightly worse than Gemini models. Or Gemma models are slightly worse than Gemini Pro or Flash models. So for the database upload, we use the Firebase admin SDK, use the JSON file as a key to write data to the database. From the previous functions, that's where all this data is collected. They're put in different functions, and then this article data structure is made and then sent to the Firestore database. This is the application development part of the project. So this is what it looks like in Flutter. Oh, sorry. This is what it looks like in Flutterflow, and we use Flutterflow out to do the entire application development. It's all GUI based. There's no actual programming that was needed for this part of it, but it was natively supporting for Google Firebase, so we didn't have to do any extra programming for that part of it. It compiles into an APK format for Android at the command line. This is what it looks like. So these pages, you can expand and close these so you can just quickly check it out. Here's a video of how the app moves around. How would you take this further? All right. Any questions?
Yeah. So the only part of this project that AI is used is to summarize
Yes.
the article.
Mm-hmm.
Yeah. And I'm assuming you can control.
Yeah, we control
how
through
much
the prompt.
information to be displayed and what format and that kind of stuff. Okay. Now, about sports, there are lots of competition in the market.
Yeah.
What I was thinking about it was that as a university professor, sometimes it's very time consuming to find literature for the project I would look for. Like I go to the website here. Is there any librarian here? No, it's here. So I go to the website and I enter my keywords, and no matter how much I play with the variables, I end up with a long list of hits that majority of them are not what I want. So I was wondering if this can be customized for literature review in libraries.
I could see that.
Yeah,
I could see that because really what we're trying to pull from we could use AI to actually pull categories from the text, essentially.
Yeah. So basically, I don't know how much you're familiar with the scientific databases. It's that there are websites, we call them databases, and you go there. You can go either one by one and search for the article you want with the keywords that you want, and then they give you what they have. But there's a chance there are duplications. You find the same thing on multiple databases, or it might be very exclusive. Like it's the only one database that has it. Or you can have some sort of a search engine, kind of like this, that pulls everything from those databases and summarizes the article the way I want. I want the articles that have data analysis, they have samples, they have used a particular model to do the analysis, that kind of stuff. If the AI can do that for me, I think that can be a very time-saving tool for people like me.
For sure.
I'm wondering, doesn't the available AI platforms like ChatGPT or Gemini already does that?
Well, if you remember a few years ago when OpenAI started ChatGPT, there were lots of fake references. Like, yes, it gives you an article with so many references, but when you go and look for those references, you cannot find them.
Or it may not even be applicable to
And secondly, it's whatever data is available, even if there's some fake news, but that is available more online.
Yeah.
So
that was I don't know. They call it hallucination. They were hallucinating. They were giving you things that does not exist.
Yeah.
So.
But yeah, I think in that domain, they're for example, in their domain, they look for gambling filter, and the kind of information for sporting website would be presented in a different way. So it would be quite it's summarizing, but imagine if they're working on academic literature, it would be totally different.
Yeah.
Because the papers would be in PDF format,
Yes,
text
exactly.
format.
That's true.
And
Many papers wouldn't be open source, so they'd only have access to abstracts. Then like certain conferences and like certain places are more reliable.
Charts and graphs involved in it, yes, I agree.
Are you saying you want to, like, you would want this to be implemented, like, in the school's library database? Like,
Yeah, something like that, right?
that would cut
That would be a good project, yeah.
ISU library uses that.
Yeah, they could definitely do a similar querying of
Yeah,
like
and
my,
connect that to the databases that they're subscribed to.
yeah, they could integrate
Yeah.
that.
that would improve the authenticity of the data.
Yes, yes.
Because it won't pull from random outside sources. It'll be a
That's right.
curated list of things,
That's right.
Yeah.
which should be pretty helpful.
I'm sure they are using some sort of AI system in the background, but
Yeah.
the way it is functioning right now, it's not very efficient for a person like me.
And a lot of people
Yeah.
have problems with like the search functions anyway. So like,
Yeah.
if there's maybe some way we could use the AI to help you find the right keywords to find the articles that you're looking for, that could be also a possibility too.
Yeah, it could maybe have like a pool of like recommended keywords depending on what you're looking for. It could maybe recommend that.
Yeah, so for example, for me, when I'm looking at it, I'm not a computer scientist, so I'm just looking at it from the user perspective. Let's say for a person like me, instead of entering keywords, I put a description. So okay, I'm looking for articles, uses human subjects about this and this particular problem, and have a data analysis and charts and whatever, and then published in the last 10 years, something like that.
It could definitely be.
So essentially taking plain text, what you want,
Yes.
and instead of having to go through all these filters,
Yes.
it just does it.
Yeah.
Yeah. I see that, for sure.
Yeah, but like their current your project is not AI focused. It's website development,
That's what I'm saying.
app development, scraping web information.
Yeah.
It's
And
interesting to get the experience
there
with
are
it.
many aspects to it, but yeah, that kind of project can be more.
The application they imagine
Yeah.
kind of triggered this thought in me
Yeah.
that, okay, if they can do this for the
Yeah.
news, then you should be able to do it for news.
I mean, I would have never thought of that, so thank you.
Yeah, but the main purpose is rather than reading all the articles, you have a quick summary of sports, what's going on in the sports world.
And then you can be like, oh, I like that article a lot, and then you can choose to continue further to read the whole article. Is there any other questions?
Thank you.
Thank you.
So you got your license plate.
We got a license plate. It's mainly for holding it.
Yeah.
All right. So I'm Melford. Oh, we actually do need our computer.
I walked up and I was like, oh.
Do you have our phone? What's up?
I thought we had a computer. Well, we have a
I thought
Jason,
you
grab your laptop.
Did you want to use mine?
You're recording.
Oh, well.
We have Jason's laptop.
You would test the functionality of this? Yeah, so if you see steam coming from the top of my head, everything's fine. Cool off later. Jump in the lake. Oh, yeah. Oh, same on the
The point that can be an idea for next year's project.
Yeah, honestly, and I've seen someone, that keyword thing that you said, like searching a keyword in a document, I know somebody did a project like that, of like, given a document,
Like they scrape information from particular kind of websites and then.
Anxiety? No, last week, I had anxiety.
You have practiced it already.
No, I said anxiety, where's anxiety? Oh, anxiety.
Oh, you're saying exactly. Yeah.
I was like, I thought he was here.
He is very busy teaching schedules, yeah. But yeah, he was here for some. But yeah, he was looking forward for your presentation.
Don't worry, I'm recording. She's at SpaceX right now. Yeah, that's what she interviewed. She's interviewing. I remember she did this interview for SpaceX.
That's cool.
She just finished, I think, like 2 rounds right now of interviews, and she's going on.
They have funded her travel
Oh,
and
yeah. Oh, beautiful.
Yeah.
All right. I guess we're ready. This one. Just move that out of the way. Yeah, let's do it. All right. Good afternoon, everyone. My name is Alec O'Connor. My name is Martin DeMont.
I'm Jace Hawkins.
And today we're going to present our overview of the parking validation module project. So just to get started here, we're going to get a brief overview of all the roles and responsibilities of everyone in the group. Again, my name is Alec O'Connor. I'm an EET major, and I'm the project manager as well as the primary programmer of the image recognition system, which I coded using Python.
Martin again, and I'm a ECET major, electrical computer engineering technologist. I developed the pipeline for the backend systems, so API server, database, enforcement logic, notifications.
As mentioned before, I am Jace Hawkins. I was more responsible for hardware systems integration, which usually includes like the Raspberry Pi and its camera, how I got that, and then of course scripting with the OS that we used.
And so just to get started here, we're going to give a brief overview of the project as well as some of the pre-planning involved. So, again, our project is the license plate recognition device. It's designed to verify parking validation of a vehicle in a private lot. This device is capable of taking a picture of a vehicle, scanning its license plate, and running it through a database to verify the parking validation. This device is compact enough to be mounted on something like a drone, and can scan multiple plates in a single image. So here's just a brief sort of snippet of a Gantt chart, which is basically the timeline for this project, seeing as when we worked on certain parts of the project. You can see we have colors for each of the project members. We first focused on getting all the research done for the project, and then we worked on actually implementing many of these features. And then also we have for each of those sections a breakdown, a work breakdown structure of each of the parts of our project. As you can see here, just a breakdown of each of the individual parts of the whole. I hand over to Jace to talk about the hardware.
Yes, so the hardware mentioned before was a Raspberry Pi Model 5, that was a 4 gigabyte model. That's what the image recognition program and the camera runs off of. And for what I was using for scripting, it usually used the Linux terminal and Python for the scripts. The camera mentioned was the RUCam camera module 3. This plugs in natively to the Raspberry Pi, and it's capable of capturing 12 megapixel and 4068 by 2592 res image. That is near 4K, but almost any image can work in resolution-wise as long as the text can be recognizable. So for the development process of the camera integration with the scripts, I had to use the terminal for those scripts, mainly the RPI cam library that directly interface with the camera to get us a viewfinder so we actually see what's going on and actually take pictures. Whenever I confirmed that the camera was working, I was able to create a keybind and initial test scripts to make sure that we can actually get this thing off the ground and automate it. So I created a text file with a script, created a directory of home, user, and scripts. This is pretty much just a directory. So whenever I create stuff later, it can point to that folder, tell, hey, this is where the scripts are. And then after I got that, I bound a keybind, Control-Shift-Q, via editing a file called rc.xml, which is in a .config folder. And this keybind pointed to the location of that scripts folder to have it be able to execute. And with that, now that I got a keybind up, I started to create a script for it to start on boot up. However, there's a small issue with that, because how the RPI cam library and commands work, only one instance of it can be ran at a time. Therefore, I had to do a bit of adjustments to the script, mainly the keybind having an extra line to kill any instance of RPI cam So then it can start back up and pretty much just almost cycle in on itself, like killing the current process and starting it itself up. This is so to prevent any form of conflicts with the auto-start script and keybind. On top of the rc.xml folder and the labwc config folder, I also added an auto-start folder, or an auto-start file, sorry. This pointed to those opt scripts to run on startup. And after a while, whenever Alec helped created the image recognition code that was used in Final Product, we were able to compile the script for use outside of a code editor. So I was able to run the code without being an editor and can be bound to that keybind or auto-start scripts. This is done via the Pi install library, and the finished code got implemented in the autostart and rc.xml files, which replaces the old testing scripts.
Alright, now I'm going to give a overview of the actual image recognition program that I created. So here is just a brief little flow chart of how this whole process works. It will capture an image and process that image so that it can run it through the automated license plate program and then rip the numbers and send it to our database. So first it'll pre-process the image where it'll first resize the image to a smaller resolution so it's less data to work with. Then it'll grayscale it, which will remove the color from the equation and further lessen the amount of data that it's taking in. Then it'll denoise, which will just remove some of the digital grain from the image. Sharpen and contrast the areas around the license plate so that it's not getting confused by anything else in the image. Then we use the fast AOPR library to implement two key features in this project. First is the YOLO detection model, which is an object detection software which is pre-trained to identify vehicles and their license plates, so that when it reads the text from the image, it's not getting, again, confused by anything else. So it'll recognize multiple cars in the image, see the license plate, and then pull it, a smaller image like there, as you see here, into the OCR, which is a optical character recognition program, which interprets the plate's numbers from the cropped image from the YOLO detection model. And as you can see here, it'll show the license plate number here, a confidence rating here of how confident it is that it read what's actually on the license plate. It does actually also give a region of where this license plate from, so this is a universal application.
International.
Yeah, international. Yes. Then, as I kept saying before, this can scan multiple vehicles in a single image. And I also implemented if the confidence is under a certain threshold, it'll rescan the image to better get that percentage up. And if no plates were found, this image will be retaken and rescanned, so it'll automatically do this whole process. Then, finally, it'll connect to the database, which will send the following outputs. It'll send the license plate number, the confidence percentage of how confident it was, the timestamp of when the picture was taken, the vehicle model that the vehicle was captured in, and an image type of reference, meaning that it'll show the actual image that was taken from the drone so that the person manually reviewing all of these license plates can actually refer to that image if they had any hiccups or wanted to just double check if it actually was an invalid parking situation. And then additionally, the program will also create an annotated reference image, as you can see here. It'll mark out where the license plate is, provide the license plate number above it, and the confidence percentage next to it. And if it took multiple images of multiple vehicles in a single image, or one image, multiple vehicles, it'll do this for every single vehicle in it. I had an example, but the file got corrupted, so that's what I got. All right, Martin?
All right. Let me get this back, not get sweaty. Anyway, so I'm going to take you on an adventure for the backend system that I developed, the architecture. The next slide is going to show you just an overview. So the huzzah! So we have the OCR producer, that's the camera, right? And it will connect to the API server. So it's connecting to HTTP post. And then there'll be authorization, an API key. It'll normalize the input. Now, their program is supposed to normalize that input. There's going to be redundancy, but that's okay, all right? So my program, the API server, is going to take that license information. It's going to make sure there's no spaces, no special characters, make sure everything is proper before it gets input into the database. And then once it is, it inserts into plate sightings table. That's one of the tables. You're going to see a list of what they are that goes right into the database. And then the enforcement worker, it's running the entire time. And it's viewing, is anything happening in the plate sightings? Unprocessed means time to select it, start processing it. It'll insert information into the events table. Again, you'll see more about that later. And then if there needs to be an action that needs to be taken, it'll insert notifications into the notification table, right? And then the mailer service is acting on its own as well, looking at the database, and it's going to take that information and then process it. So before I talk about the API server, which is the control entry point, first of all, I created the API server to simulate what the school would have and their servers and the networks and all that. And so this is the plate sightings table. And as he's already spoken, Alex, plate text confidence captured at location image path. But I only truly need captured at and plate text for everything to function properly. So if these are null, that's totally fine. But then more information is helpful for the emailer, right? So because security is going to be emailed, or the individual who has an account with the school, they need to be notified, hey, we found this, your permit is expired, you owe us money. So with the API server, I was trying to figure out, hey, what can I do to make the database a little more access friendly, right? How can I reach it if it's not local? And so I decided to make an API server that would then be connected to with their OCR program. And I used Flask, which was Python based. Thank God that Python has a lot of capability, and I just had to download it and write up the program, and bam, it started working. So the program only accepts post sightings, right? So you're not getting anything from the API server. It's sending out a signal, and you have to connect to it through a authentication key. That's as much security as I put in. But if I had Caleb, that would be great. You would put in a lot of security, wouldn't you? But yeah, so validates through API key, JSON format, normalizes plates, and inserts into plate sightings. This is the database design. I actually developed this before anything else. We have several. We have the plate sightings, which you've just seen. It stores incoming plate detections from the camera. Then the permits, so it needs to check on something, right? How does it know if there's anything, if the vehicle is allowed or not? So I create the permits table, determines whether a vehicle is authorized, and then the owners table, so like emails and phone numbers and such. The events log will log everything that happens, even duplicate licenses, license plates that are taken. Notifications acts as a queue for sending enforcement actions like fines or alerts, and then scene plates, which is one of the most important tables in my opinion, because this prevents duplicates, and you're going to see why right here. This is the scene plates. I created a unique key, meaning that one of the first things the enforcement program does, it sees unprocessed, it takes the plate, it takes the date, today's date, and it shoves it right into scene plates. And because it does that, it's unique. If it happens more than once, it fails, it defaults, and the program stops. So you'll never get a duplicate until the next day, right? And that's how that works. But the enforcement engine, rate on process sightings, normalize and validate the plate. That's the third time it's doing that. That's a redundancy that was on purpose, and that's okay. Check permits, the permit table, apply deduct, which is scene plates, create an event, queue notification, mark processed. And this is the entire table, the entire logic of essentially the enforcement program. So we start here, plate sightings, queue. So it always starts as unprocessed, right? So the moment it receives anything from the OCR, it sees unprocessed, and because of that, the program the enforcement program will see that and start processing it. It can go up to a batch of 50, we can change that. I've done 100, but 50 is the limit. It'll normalize, as I already told you, and then it'll ask, is the plate valid? If it says yes, look up the permit, permit active. If it's yes, log insert permit event mark process 1. So we're ending it, right? Because it's an active permit, there's no action that needs to be taken. But at the valid plate, if it's not valid, classify as unknown vehicle because it's not, there is no plate in the table that was founded. And then we go through this process, but just give me a second. So if the permit is not active and we have the license plate, meaning we have your email, your public student, or your professor, it goes no, not permitted, unknown path. Was it seen today? Yes. So has it already been processed? And it does a duplicate event. I already shown you that. But if it wasn't seen, then we check for the owner email. If there is an email, they get billed. If there's no email, send a security notification. And so if an email is generated, the mailer, they'll see it as pending, they'll change it to sending, and it's sent. But this is all happening in a split second. This entire thing is literally 1 second. So you'll actually never see sending happen live on the table. It just gets processed instantly. So these were the key design decisions for the pipeline. API-based ingestion. I didn't want anything to touch the database directly besides the API server. I didn't want it to be OCR to database. I wanted to keep things separate. And this also produced a way to utilize a network and do so long distance. There is wall mode for concurrency. When you're using SQLite, there are several modes to it. If you're not using wall mode, which the enforcement program activates, if you don't use wall mode, then you can do multiple reads, but if you try to do multiple writes onto the database at the same time, it'll lock the program and shuts down. So wall mode allows multiple reads, and if there's something being written and another program is trying to write at the same time, they'll pause that program for a couple seconds and it'll try it again. So the database never locks. This is very safe mode to do. The polling worker, polling simply means that it's constantly accessing, but with the email and the enforcement program, we can limit that to every 5 seconds, check the database, and do other configurations. But I use polling, which you'll see in the video that's coming up next. I did separation of concerns. So there's multiple issues that I had to solve. So I created several solutions that are separate from each other. I could have combined all the programs, API server, enforcement, mailer script. I could have done it all at once. But for me, I didn't like how that worked. And I found out that in a systems base, like out in the real world when you're developing something, you want to separate by separation of concerns. So I created, they had the producer, I had the enforcer, I had the mailer, and the API server. So this architecture reflects real distributed systems. That's how this works, even though it runs locally.
All right, so I know that was a lot of information, but we actually have a pretty brief demonstration of the whole thing running. Okay, so this is the program that's running on the Pi. This is the image recognition program, so we're going to run the program. It's going to automatically bring up the license plate, see that there's a license plate there, and boom, process it. One plate found, one plate, reads the license plate number, saves the image, and then see 97.6% confidence rating, and instead it's 201 means it was successfully sent to the database. Now we're going to do another scan showing the duplicate process. If we scan the same plates, we're going to scan the plate again. Image received, same thing. Then if we go into our annotated images folder, boom, there's our license plate number on top, confidence percentage, box around the license plate so you can refer to this whenever you need to. Then,
I might need that back.
then on the database side, we have 4 windows. It'll make sense.
Several programs. Can I see that?
Yeah. So, boom, it logs the sighting of the license plate. Then, right there, unknown vehicles. This is the first time it's seeing this license plate. Then the mailer. Okay, there, if you want to describe that.
Yeah. So I'll show it to you all again, but this is what's being sent out as an unknown, so security is receiving this email. It'll give the plate, location, and captured at, which is all information that they provided from their OCR program. No active criminal was found in the system for displays, action requested, please verify the vehicle registration. And because they have the image path and all that, then the guy can also look at the image path as well as go to the parking lot, check the license plate. This is the database from earlier that I was showing you. Plate text, and this is live, so it just got updated. Go ahead. And you're going to see the duplicate happen as well. So I just switch over. There it is, duplicate. So this was the first one, second one happened. And then I switch over to show you plate sightings. So we see both. Oh, no, it's fine. It is what it is.
Yeah, but as you can see, the duplicate sighting and everything.
Yeah.
Everything.
And I was going to I was going to show you the notifications, but that got cut off. But notifications only send out one email. But the events table always updates. Yeah, it always shows this is what happened today.
All right. Any questions?
I think it's more of clarification. So even if like one license plate is duplicated, only one email will be sent.
Only one email is sent, but it will log the event in our events table just so it knows that hey, we already got this one.
The
It will
scene
only
plates.
send one.
The scene plates table prevents all that from happening.
Are you supposed to like reset every day or what?
Yes, every day. So it is time-based, meaning that midnight. So midnight, if your car is still there, well, now you're getting charged again. And you shouldn't be there anyway. You're doing something wrong. Any other questions?
I think you guys did some pretty good work here. Just as a representative of the student body, Parking Services already has the ability to ticket us all as much as they want.
Oh,
We
yeah.
really want to help you.
That was
It's a concept, okay? Nothing to be
Concept.
Yeah.
Concept.
It was just a capstone, guys. Yeah. Any further questions or comments? All right.
Thank you so much.
Thank you for having us. Sorry about the sweaty clicker.
I see the.
Thanks, guys. Oh, we were within time again. Oh yeah, dude, that was great.
Sorry about the
Representative of the student body. We're playing the villain, but also.
I had not tried it, but I had there is also
I tried to do the 2 years old. Yeah, I started watching videos. It's really
Yes. If I hadn't learned, if I had known how to use it, I would have said it was like half.
That's what I should have done. Because I think that this was you guys want to go start at this point? This would be the little stars. Why is this so much?
I don't think it's because we're trying to do more. We try to do it see how the people come together and an application in order to this is your
I do like the color grade. Color grade.
Yeah, they can
Just some of
Should be understood.
Yes. Okay. So yeah, guys, yeah, you know that Leah is also part of this team, but she is traveling for SpaceX interviews. So she has made it to the final
Interview process.
level of the interviews, and they had called her to Seattle. So she has her interview today. She left for Seattle yesterday. So she had put the audio narration for some of her slides, and it's a nice demo. So that part is covered like that, and Edgar and Gavin are here to cover their portions of the project. So, yeah, I let them.
Alright, so I'm Edgar, this is Gavin, and this is our lead is here, supposed to be here too, but this is our Smart RC Rescue Rover.
Yeah, can we raise that volume? Oh Lord.
Laptop shouldn't be, but yeah, it's downstairs also. Yeah, maybe that did help. Yeah, increase it.
Hello, my name is Leah Tice. I'm the project manager for this project. I kept the project on track till completion and did a good bit of pretty much everything. I was mainly responsible for the firmware and software of all the components on the remote controller, as well as the rover. I was also responsible for designing and creating the circuits for all the sensors, motors, and communication links.
I'm Edgar. I was responsible for the hardware fabrication, translating design into assembled products, managing all the physical wiring to our rover, and the lead system integrator collaborating with Gavin to physically install and mount all the hardware.
I'm Gavin. I was responsible for 3D printing the majority of the 3D printable components for the rover. I was managing the digital fabrication process of said 3D parts, which includes the printing of said 3D parts. And I was in charge of making sure everything for the rover was able to be put together properly.
So I will be going over the overview of the project, basically what our project is, what it's about, why we did it. So whenever we were trying to figure out our project, we identified a certain problem. And the problem was that there was an inherent risk for all first responder occupations. And when I mean first responder, I mean EMS, so emergency medical services, law enforcement, fire and rescue, as well as military. Just because people choose these professions doesn't mean anything. All life is valuable, and so all life should be protected at all costs, even though these people choose to do these dangerous professions. In 2024 alone, 147 law enforcement officers, 20 police canines, and when I mean life, all life, I mean all life, including animals. 62 emergency medical service professionals, 74 firefighters, and 341 military all were killed from some sort of duty-related action. This does not include any kind of suicide, mental health. This is all duty-related. Once this problem was identified, the solution we came up with was a remote rover with a first responder safety first mindset to act as kind of a first in scout in hazardous areas. The requirements for this rover that we identified to make it actually work and be useful is that it would need vision, movement, detection capabilities, and response capabilities. These four things, these remote features would help limit first responder exposure to toxic and hazardous environments. And that's where our rover comes in, the UE support rover. This rover, it's a prototype obviously, but the features that we feature on this particular rover has fire and rescue personnel mainly in mind. So being a remote action-oriented robot is the main driver of the safety first concept. But for it to be functional on a remote basis, there has to be some sort of environmental awareness without any kind of human intervention. So to satisfy the requirement from the last slide, the rover features a live stream video feed to satisfy the vision requirement, time of flight sensors for the autonomous functionality, an R385 water pump, which satisfies the fire response and suppression requirement, an infrared flame detection module for fire detection, and a site-independent drivetrain to allow for higher degrees of maneuverability in unknown and hazardous environments. Alright, so the next slide is going to feature a small demo of the UE rover.
Tactical precision, engineered for the hazard. Autonomous suppression, critical.
So communication architecture. Our rover.
Yeah, that was amazing. Yeah.
Bring it back.
So communicate.
That's back. Yeah.
Tactical precision, engineered for the hazard. Autonomous suppression, critical intervention. Online.
So communication architecture. Our rover implements a hub client model, the hub being the microcontroller that's on the rover itself, which is an Arduino Uno or for Wi-Fi. It creates a private access point and it's its own dedicated local network, so the controller connects to it, and so does the live feed camera, because those are two separate microcontrollers too. On the controller side, there's an Arduino Nano 33 IoT, which acts as the client. So it shoots UDP packets to the rover, the R4, and we chose UDP because it doesn't require a handshake, and that gives us lower latency because we don't want something getting snagged up somewhere. These UDP packets, they hold data from the joysticks, the fire suppression, the autonomous mode, and so we need those to transmit in real time. The microcontroller on the left is an ESP32 CAN. This joins the same private network, and it handles the vision and vision only. It just provides a live stream of JPEG pictures, actually. It's just shooting them really fast, so it makes it look like a video, but it's actually just a bunch of pictures. So we use UDP packets for communication between the rover and controller. Our packet is designed to send a 6-byte packet, and each of those bytes corresponds to a certain control on the remote. What happens is the nano in the remote sends the packet to the Uno in the rover every 5 milliseconds. Using a separate microcontroller, the ESP32 CAM for the video feed helps keep this payload small and minimizes processing in the Uno when the nano sends the packet. In our UDP packet, there's 6 bytes. They're indexed 0 to 6. Byte 0 handles which mode the rover is in, manual or autonomous. We use the ASCII value 65 for uppercase M or A and 77 for an uppercase M to represent the autonomous and manual. Bytes 1 and 2 correspond to the left joystick, and bytes 3 and 4 correspond to the right joystick. The values that represent this are between 0 and 510, which gives us precise control over the speed of each side of the rover since we're using the P.2 signals. Byte 5 is the button for the water pump. When the button on the remote is pressed, this bit is flipped, and it triggers the logic level MOSFET on the rover, and that's what activates the pump. So this was a high-level overview of what the project is and how it works. Now Gavin and Edgar will go over the more intricate details of each individual system.
So here's the mechanical overview of said rover. This is going to be the physical components of the majority of the stuff that was 3D printed. So the methodology of said rover, iterative design process, which was for systematic loop analysis, planning, and development, and testing of said parts for the rover, verified by decomposition, means you slice the model into smaller fit test components to verify the tolerances of said components. This allowed for a rapid design, print, test cycle while keeping waste at as minimal as possible, the waste being the 3D printing waste, or the resin and whatnot. And after verification, it was able to be reintegrated, verified components, and finally unified model before production was correct. Yeah, training notes. So the design for the prototype features an open layout, multiple areas to mount modular fittings, which allows for hot swaps during design and testing. The wheel shaft utilizes a hexagon shape to fit into a custom 1.9-inch wheel, which increases the surface contact. And the front and rear motor mounts have snap-in brackets that hold the motors onto the frame, which provide a secure fit and alignment during skid steer maneuvers. Water reservoir, it's gravity fed, which has an integrated constant slope to allow for constant positive pressure at water intake valve, curved like that. So it utilizes a custom silicone gasket to ensure a waterproof seal, and the water reservoir on the R385 pump mounted on the chassis bottom, or mounted onto the chassis bottom to create a physical firewall between the main electrodes and the water, which just means it's there to prevent any water from getting on into any of the electrical components, which prevent any damage to said rover's internals. Battery housing, or engineered reinforced mounting flange for direct threaded integration with the reservoir bracket. Features lateral thermal vents and posterior exhaust that facilitate airflow, which creates passive ventilation to further the thermal dissipation during high current discharge cycles, which for instance are the pump being used and the motors for propulsion also being used. And utilizes low profile geometry to not mount flush against the water reservoir and the brackets, maximizing internal volume of said rover chassis. saving space on the internals. The camera, flight sensor, and LCD screen housing. Engineered recessed housing is designed for mounting onto the internal mounting plate for optimal stability during movement. So it utilizes a dual bore fastening for the EL array. Features custom contour seating supported by 3 angles. And so this is the LCD screen mount. The LCD screen utilizes a resting bracket and is secured with fasteners to ensure structural rigidity. So handheld HMI, the handheld remote controller for the RC. So shaped much more ergonomically than the first version of the controller was. The first version of the controller was much more of a rectangle or brick, which was much less comfortable to hold than the shape that was come up with later. The dual status indicators for the LEDs are mounted in the upper left corner of the controller and are indicators. The green LED provides a visual verification of successful UDP handshake between the remote and the rover. And the red LED provides visual confirmation of autonomous firmware being active. The logic control switches, which are mounted in the upper right, are a red switch and a black switch. The red switch indicates the primary power managing the VCC distribution from the internal battery of the controller. And the black switch facilitates manual HMI control and autonomous logic control system states, which is just a flip of the switch between 6 states. The joysticks, which are mounted, which are these 2 holes in the controller base, are utilize the 10-bit ADC to provide high resolution differential thrust control, which is just movement, and the tactile button interface for the MOSFET gate actuation of the R385 water pump for starting fire suppression, which is that is with the button for set system use. Wheels and tires. The tires themselves were fabricated from and just molded in-house, basically. The custom tires used a short silicone rubber composite with black pigment. And the molding process was most successful with a 24-hour curing cycle, which ensured consistent structural density and tear resistance. The custom 1.9-inch bead design with integrated hexagon-fitted hubs to ensure the 100% rotation torque transfer from 1-9 gearboxes on that surface. Make sure to mess up. Moving on to here.
This is the electrical systems of the rover. For the powering the entire rover, we used a 11.1 volt LiPo battery that could discharge high amounts of current. But to for safety, we installed a 5 amp fuse by the rover's power switch. Here. To not really short circuit the Arduino or give it pretty much all the voltage from the battery, we connected a buck converter to the battery and set it to a 1.5 volt output for the Arduino input voltage, and all the components share a common ground. For the propulsion system, we installed dual L298N drivers to allow for pretty much individual mobility, and it's powered out directly into the 11.1 volt battery with significant voltage drops between 1.5 and 2 volts. In the drivers, they have 4 190 gear box motors for superior torque and better power when steering. And they have metal gears to ensure that they don't break easily, rather than plastic gears, and just limit the wear and tear that other gears use. For the pump cooler, we used a IRL Z44N logic level switching for the high current R385 water pump. it is connected to the pin 9 on our Arduino. The gate, or the drain is connected to the negative terminal on the pump, and the source is connected to the master ground on the battery. The positive terminal on the pump is connected to the battery positive, and we installed a 10K ohm hold-down resistor to ensure that the water pump doesn't just stays off and isn't shooting water forever. For the DC motors that we use, they create electromagnetic interference that can induce voltage spikes, which can have like a kickback on our components that we use, like our Arduinos and all that. So we installed a 1N4007 flyback diode on the 12-volt water pump, just to ensure that when the pump stops, it creates or when it does create a high voltage spike, the diode protects it from it and kind of recycles that energy back into the rover. For the sensors that we use for the autonomous mode, we installed 3 atomic flight sensors, implemented X shut sequential logic to rename the addresses. The address that it uses the 0x29 for pretty much all the sensors, but if that was the case, each sensor would do the same thing when going in autonomous mode. So to kind of differentiate that, we had to give it some different addresses, one for moving and looking left, one for moving and looking right, and the center one as well. And then for the flame detection, we use an IO receiver optimized for the wavelengths between 760 to 1100 nanometers. This band is what primarily emanates from the open flames. They output 2 signals, digital and analog. Digital for the flame detection itself, and then the analog for how intense the fire is, just to kind of pinpoint it out. And it's set at approximately 12 inches using a potentiometer. Any questions?
Okay, so I have a question. So this mover that you created, and a little bit, the technical explanation was above my head. But is it going to find the fire and find its way toward the fire, or it is remotely controlled by an operator?
It's remotely controlled by the operator itself, but in the event of first responders not being able to kind of be in that area of the situation itself, there is the autonomous mode that lets it kind of navigate towards that fire and put it out.
I'll add on that, and they have the wireless video streaming in the initial slide. It was mentioned that.
Yeah.
So, like, you are controlling it, but you also are seeing what it's doing. And currently, I don't think like they have implemented a lot of autonomous features, but it's like even when it's autonomously moving, operator can get the control. So like the operator is saying they are not in that hazardous environment, still they are controlling.
So this is a very small model that you made, right? Yeah. So if you want to scale it up, like in a real, how much, let's say, water or in general, fire extinguisher, it can carry?
How much would it carry right now without like?
It's hard to say.
Yeah, they have to use different motors, so the design would be same, but the power level of the, because
yeah, that's what I'm saying. Because
in fact, like to begin with, they had, even with small, their motors, like they had put these tires,
Yeah.
and even with this, the motors didn't move, and they put the motor drive, and to see like how the torque is increased, because they need way more torque. They have 3D printed all the parts. No, it can't be plastic if it's going
Yeah,
into.
I intentionally asked that question because when you scale it up, then you have to weight up the vehicle, you have to weight up your hardware, and then on top of that, you have to carry something in order to put out a fire. And too little is not economically feasible, right? And too much might make it very expensive or slow to respond. So I don't know. If let's say the model is good and everybody likes it, and then how do you, if you want to scale it up, how big you can go in order to make it practical? Is there anything similar to that? Let me change the question. Is there similar to this vehicle that you are designing out there that does similar things? How big they are, how much extinguisher they carry?
I don't think that they have done more research on that part, but like they are now, I've worked with another project with fire extinguishing walls. So those is not water, there's like specific chemical material. So based on that, we can keep the size not way big, like keep it small, but obviously it wouldn't be the 3D printed plastic version. So that part, but as a part of the project, they did a lot of 3D printing and all that.
I mean, I thought the size of the unit was dependent on essentially the general size of doorways. Because this is supposed to go in instead of the firefighter. Am I correct or am I misunderstanding?
Yeah, you're correct.
Okay, so like the general size of the usual door, and maybe you have several models for bigger doors, right?
Yeah, but then there's also a trade-off between speed and weight.
Absolutely,
Like if it's smaller, you may make like more powerful drives. You can make it faster.
And I figured its purpose is not to actually extinguish fire, but really to map out what's going on in the fire in a safer way, so the firefighters don't.
They're more. This is more of a prototype, and
Yes,
more like
of course. That's what I'm saying.
So it's not, but yes, it is inspired by that idea, like something like that.
Yeah.
So yeah, you can also say that it's like you're monitoring the pace, but then you can also have the extinguisher on it, and that's like obviously like if any place, not exactly fire where like it's hazardous and you have something like that, and
I think the thing it's most similar to right now is sort of a UAV, but instead of dropping bombs, it puts out fires inside buildings.
Yeah.
It's just a remote controlled vehicle that someone is going to be driving around, hopefully outside of the building from a safe distance, and they're going to be able to use that to, if we ever have a solid design that is able to actually go inside a building and carry a payload that is enough to put out a fire, they're going to be able to use this on the smaller end, I'd say. It's probably going to be about the size of like a medium or smaller dog at the most. I'm pretty sure when we get everything working, if we ever do. And then be able to put out that fire safely and map out the building inside, hopefully too, with the camera that's mounted on the drone. I think that's pretty much the idea we've got for it right now. Okay. Sorry for that.
No, that's okay. I mean,
and then, like if we think of like practical applications and
I know,
like that would add a lot to the project.
And thought into scaling it up, unfortunately.
I mean, that's fine. I mean, it's sometimes the scope of project that is defined to you doesn't include that. That's fine.
Yeah.
But I was wondering. Okay, it looks nice when it is like a toy, but how it's going to look like when you are scaling it up.
Right.
I think I have a similar question. What is the accuracy of your design? Did you simulate that?
The
accuracy.
accuracy of your design? Do you elaborate?
Yeah, did you do some simulations after you designed?
They have actually tested.
They have a prototype.
Yeah, they have made this robot and they have run it in the. I'm not sure. Did you see the demo from you?
Video.
Yeah, you can replay that. So yeah, there you can see the size, and I think like if the material is different, size is slightly bigger, that can work.
Engineered for the hazard. Autonomous suppression. Critical intervention. Online.
So it's really hard to see those shooting water.
So it detects where the flame is, and then it extinguishes it. So it's not like they had manually put it, and like when the fire is extinguished, the water flow also stops.
Just two things about the demo. And one is, I love the cat, how it was scared and hiding behind that thing.
Yeah.
Second, next time, if you want to do a demo like that, put it outdoor. You have fire inside the building with a car.
From your safety background.
Yeah.
So yeah, that was
Do it outdoors, because you have fire in a room with a car. Not a very good idea.
Not a good idea.
Thank you.
Yeah, so they had tested that.
I have melted.
So, yeah, no, there are some video presentations that I can play those. Yeah, there are 3. So, yeah, it's your choice if you want to.
So,
The next one is for IT.
Oh, right, these are the online presentations, I think.
Oh, yeah.
Yeah, the